Hello, Happy New Year. Welcome to Anu's first podcast of 2024. We have been driving thought leadership ideas around VLSI design by discussing design automation related challenges with our esteemed panelists. My name is Krishna Banka, your host for this podcast. I have over 2 decades of association with semiconductors and electronic design automation industry. My guest today is Dr. Satya Gupta. Dr. Satya is the president of VLSI Society of India. He has been actively contributing to the global semiconductor industry for 40 years. Welcome to the podcast, Dr. Satya. Why don't you introduce yourself to our audience? Tell us about your professional journey.
Thank you so much, Krishna, for inviting me to your podcast. Uh, I started my career in 1983 when I joined a research group at IIT Delhi. And since then, I had a good fortune to work basically at large corporates, uh, four successful startups, uh, public platforms like India Electronics and Semiconductor Associations, EPIC Foundation, VLSI Society of India, and also work with the government to create an atmosphere and ecosystem for making India a semiconductor nation. So, thank you so much for inviting me to your podcast.
Definitely, your journey has been really inspiring, and I am sure the audiences of our podcast will definitely take away your valuable insights whenever they get a chance to look at this session. So let's get started. To start with, I would like to understand your opinion and what are the current design and manufacturing trends that you see in the VLSI and the semiconductor industry.
So, if you look at semiconductor chip design, or what we popularly call as the fabless companies, these companies design the chip and give it to foundries for contract manufacturing. There, I think one of the largest trend is that systems or application companies are designing their own basically chips and silicon. For example, Google, Amazon, Microsoft, all of these companies basically are designing their own silicon, including Tesla and Apple, right? So it is no more basically a dedicated semiconductor companies who are creating this large volume complex chips. It is the application users. They want to create a differentiation and basically kind of uniqueness, so they are designing their own silicon. So that is the trend number one, right? uh, Trend number two is obviously basically uh, all the horsepower and the functionality needed to drive the AI ecosystem, including basically both training and inference at in data centers and on the edge. So that's second largest trend. And third, I'll say is basically automotive, uh, both for electrical vehicles and autonomous vehicle, things like ADAS and so on and so forth. In terms of the designs, I think RISC-V is basically beginning to gain significant traction, and it's just coming out of the age to become commercially viable solution for many things. So we see in next 5 years, both globally and in India, it will become a significant architecture where basically a lot of products will be developed.
Yeah, I mean, I think really appreciate your perspective because with hyperscalers getting into semiconductor design now, the industry is definitely upgrading itself. And I would also say that there's a lot of innovation which has been triggered due to a lot of proliferation and this design work getting spread out across the industry. Now, when we talk about these trends, definitely there's a need of the talent to match what the requirements are. So, what are the talent requirements in your opinion to support these activities, and how can the companies preempt any talent gaps? How can they foresee and then work around it?
Yeah. So let's first take what is the talent requirement. So about 3 years back, So India has been running this basically special manpower development program for last 20 years. So when we were planning for fourth generation of the SMDP program, we in 3 years back, basically we had estimated 85,000 people will be needed for VLSI design work, not counting the manufacturing side, in next 5 years. Now, when we looked at the same number last year, I think the requirement is more like 1,25,000 design engineers in next 5 years for domestic consumption. And if you add basically India has to become talent supplier to the world also, then you can make it basically 1,50,000 engineers for the design side of things, right? Now,
Okay.
because of the government policies and others, since manufacturing is also start to taking root, we expect around 10,000 people, both engineers and technicians, required for the semiconductor manufacturing, which is wafer fab, OSAT, compound semiconductors, all of those things in next 5 to 7 years, we'll need about 10,000 people on the manufacturing side. So about 1.5 lakh engineers on the design side, and let's say about 10 to 15,000 people on the manufacturing side, right? Now, uh, how this basically demand can be met, right? So considering the strategic importance of this sector and the talent demand, 3 years back, basically, some of us proposed to AICT to start a BTech program in electronics and VLSI. As you know, basically, we have been running electronics and communication, electronics and
Sure.
instrumentation for many, many years, right? So we felt the in the future, this sector is going to be one of the driving force for technology and economy both. So it's better that basically we bring it to the undergraduate level also. And after basically a lot of deliberation and work of lot of people, about a year and a half back, AICT has approved a undergraduate BTech program in VLSI design and a diploma program in the semiconductor manufacturing. Now, uh, what I thought that basically once this program got launched, at least in first 1 to 2 year, about 100 institutions should pick up this BTech program and start offering this as a new degree. Uh, Good to basically inform everybody. As of now, about 130 institutes have signed up to offer the BTech program in electronics and VLSI design, and more than 400 basically institutions offer a MTech in basically VLSI design. So that should give us a good base to develop these talents. And there are many other initiatives which are happening to basically train the people for the manufacturing because that requires a different type of the setup and the skills, right? Both for packaging and the wafer manufacturing. Uh, Now, what companies can do, one of the best tool for companies which we have seen in the software industry, like software giants like Google, Microsoft, is to focus on the internship. Their primary hiring nowadays happens through the internship, and they treat the interns like basically princes and kings, right? Very, very well treated because they are going to be the future of the company. I think more semiconductor companies, both globally and in India, have to adopt basically this internship regime so that basically they can create the employees for the future.
Yeah, definitely. I mean, I see a lot of very good engineering schools getting into electronics and VLSI, and I think it has become the stream of choice also for a lot of engineering aspirants. Now, let's switch gears a little bit and talk about a few curious but pertinent themes. I think you've already touched upon them. For example, you said RISC-V, right? It has been evolving rapidly all over the place with notable advancements in recent years. So, how do you see any other specific inputs that you would like to share around its evolution? How do you see
Yeah,
it?
two things, right? Yeah. Risk 5, when Risk 5 came out of the Berkeley, right?
Yeah.
And the Kurtz and other people started a basically small startup called Sci-Fi, right? Then, about 2 years back, basically, Dr. Navid Sharmani joined Sci-Fi and he basically took it from the lab to basically global recognition, right? And basically, Sci-Fi became a momentum through Sci-Fi, Risk 5 International, and all the other platforms, right?
Sure.
Uh, so two things very important for Risk 5. One thing is that it gives a basically much broader participation for people who want to get into basically custom silicon business, right?
Right.
Because uh, it's easily available, open architecture, and all of those things. Second, and the most important thing, it's a very important tool to basically teach the students about the various aspects of the chip design. Because once you have gone through a processor design like Risk 5, you would have touched almost all the different things which we do in the basically chip design world in different companies, starting from memory management, processor, register files, everything which we do, right?
Right.
Somewhere or other get touched while basically Risk 5. So I am very strongly recommend that all the institutions which are offering this as a course should have a dedicated course on the basically processor design with Risk 5 as an example, right? And
Definitely.
India is, I think, going to be very important in basically in this whole evolution of the Risk 5. Uh, and Government of India through its DIR 5 program, DIR 5 program, and basically multiple startups, like almost 40% of the startups coming out of DLI program are basically going to be using the Risk 5, right?
Right.
And then we have program from CDAC, basically IT Madras, and many other institutions which are basically propelling this Risk 5. So it's going to be very important platform for next 5 years, where India will become more of a semiconductor product nation also, other than manufacturing.
So while we are on that theme, we're talking about the semiconductor ambition for India. So what is the vision of the Indian government? What is the current status of funding? How are they helping the industry grow and targets its ambition?
So I think, considering all the strategic importance and the geopolitics of the semiconductor, uh, beginning of 2022, basically Government of India announced a comprehensive semiconductor policy and incentive scheme, right? With $10 billion outlay. And what was the best thing about the policy? Because India has attempted basically other initiatives in the past. This time it was very well thought out and a comprehensive policy with very clear-cut written guidelines, the how incentives will be given and what form the incentives will be given. So three pillars of the policy. One is basically semiconductor manufacturing, which includes the silicon wafer fab, compound semiconductors like basically GaN and silicon carbide, and the ATMP offset, right? That's the manufacturing side of it, right? On the design side, basically it was envisaged that India need to create lot more product companies. So a DLI scheme was launched with the goal of creating 100 fabulous companies. It's called Design Link Incentive, uh, with a basically outlay of about 1,000+ crore. And third was basically the talent generation, where basically programs like C2S, which is the fourth generation of the SMDP program, and basically ISRC and all of those things come, right? So one is basically capacity building, another is research. So all of that was basically done. And the kind of the incentives were given basically under these three things are, I think they are unmatched anywhere across the world, right? If you look at the companies which are getting the incentive under basically CHIPS Act in US, it ranges somewhere between basically 15 and 25%, right? Now, if you look at India, semiconductor manufacturing, it's a 50% basically given by Government of India on a pari passu basis. And then on top of it, basically some of the states are giving 20 to 25% additional. So
Mhm.
that means about 70 to 75% of your capex is being incentivized. Nowhere in the world, basically, this level of the incentives are given today. Okay. On the design of the product side, again, 50% of your project cost plus free EDA tools are being given by the government. So that, let's say 50%, and you are from the EDA world, so let's say 15% is the cost of the EDA world. That makes it 65%, right?
Right.
On top of it, states like Odisha are giving 20% more. So that
Uh-huh.
makes it 85%, right? Now, If your fabless startup take $10 million of basically going to first product, almost 80-85% is being subsidized by the government. Again, there is no equal of this type of a thing in the world, right? Third is that more than 110 institutes basically are given free EDA tools basically to do education and research, right?
Right.
Again, and these are commercial tools from basically all the three leading vendors, three or four leading vendors, with no limit of how much you can use, right?
Right.
So I think these are very unprecedented and the first time basically I've seen this kind of the policies. So, and we have seen some initial success through basically Micron setting up their fab, and there are about four more ATMP and OSET proposals basically from people like Tata, CG Power, Keynes, and some other. And basically, about 5 to 6 proposals on the compound semiconductor for power electronics, because compound semiconductor for power electronics is going to be very important for electrical vehicle and other basically power conversion industry. So we see about 5 to 6 proposals coming in that direction, and basically multiple proposals in silicon. So my personal view on this thing is that by end of basically 2025, we will have minimum two ATMP OSAT projects, minimum two compound semiconductor fab project, and two silicon wafer fabs basically announced and started, and they will take their own time in basically maturing and starting production, right? But 2 plus 2 plus 2.
Absolutely. So I mean, I'm sure you are aware, Synopsys has also opened their new R&D office in Bhubaneswar very recently. So
Yes,
definitely
yes, yeah.
the evolution in semiconductor design and manufacturing has been inspiring generations of technologists and engineers. Advancements in semiconductor materials, infusion of AI, and novel fabrication technologies have been pushing the envelope. The global semiconductor landscape is undergoing a profound transformation, and so is India. India is also positioning itself for an ambitious leap into the semiconductor manufacturing, as you just touched upon. So, well, wonderful conversation, Dr. Satya. Thank you again for your time. Uh,
Thank you so much. And hopefully together we can all make basically India a semiconductor product nation, and anybody would want to basically talk or discuss more about it, they're welcome to reach out to me through you or basically other social media platform. Thank you so much.
that concludes our podcast. Any topics you would like us to cover, please leave a comment. Until next time, take care.
Thank you so much, Krishna. Signing off.